Hi, our lesson now is about sequences and series. In sequences and series, we start talking about the arithmetic sequences and series. The arithmetic sequence, let's see an example of the arithmetic sequence. If I have 2, 4, 6, 8, 10, and continuing. This is a sequence. If you can realize that between each term, I'm adding 2. Here, plus 2, and from the 6 to 8, it's a plus 2, and from the 8 to 10, it's plus 2. Since there is a common difference between the terms, I consider the sequence to be arithmetic. Now, for the sequence, this is U1, the first term, this is U2, this is U3, the third term. To show that this sequence is arithmetic sequence, U3 minus U2 must be equal to U2 minus U1. By this, we show that this sequence is considered to be an arithmetic sequence. So, in arithmetic sequence, we have to know U1, which is the first term. We need to know D, which is the common difference. In our case, it's the plus 2. And we need to know N, which is the number of terms. So now, after knowing U1, D, and N, we can find any term in an arithmetic sequence using the formula UN is equal to U1 plus N minus 1 times the common difference. This formula, we can use it to find any term in an arithmetic sequence. So now we talked about the sequence. Let's talk now about the arithmetic series. In a series, I have all the terms added to each other. So it's 2 plus 4 plus 6 plus 8 plus 10 and so on. In this series, I can simply find the sum of the all terms. If you can realize also, the common difference here is 2. So now I can find the sum of n terms. So the sum of n terms can be written as is equal to the sum of ui from which I is equal to 1 to n, which is the number of terms. The formula used to find the sum of given number of terms, we can use S of n, the sum of n terms, is equal to n over 2 times 2u1 plus n minus 1 times d, the common difference. Or we can use S of n equals n over 2 times u1, which is the first term, plus un, which is the last term. We can use the second one when the last term is given in our series. So by this, we can find the sum of terms in an arithmetic series. Let's have an example from the IB question bank now. One of the locations in the 2016 Olympic Games is an amphitheater. The number of seats in the first row of the amphitheater, so I know that U1 is equal to 230. The number of seats in each subsequent row forms an arithmetic sequence. And the number of seats in the sixth row is equal to 270. For part A of the question, we need to calculate the common difference. So now, for the common difference, I know that U1 is equal to 240 and U6 is equal to 270. What's the formula of U6? U6 is equal to U1 plus n minus 1, which is 6 minus 1 times the common difference. Let's just substitute 270 instead of U6. I have 270 is equal to U1, which is 240, plus 6 minus 1 is 5 times D. So now I'll be having 5D to be equal, take the 240 to the left, is equal to 30, having the value of D to be equal to 6. So by this, we could find the value of D. Now let's go to part B of the question. There are 20 rows in the amphitheater. We need to find the total number of seats in the amphitheater. So we need to use the sum of n terms formula. So the sum of 20 terms is simply equal n over 2. The number of terms is 20 divided by 2 times 2 times U1, which is the first term. I have 240, plus n minus 1 times D, I have the n to be 20, minus 1 times the common difference. I already found the common difference, which is 6. So now, this will be equal to, I need to use my graphical display calculator. I go to menu, I go to run matrix, and I plug in this value, which is 20 divided by 2 times 2 times 240 plus 20 minus 1 is 19 times the common difference, which is 6. And I close the bracket again, and this will be equal to 5,940 seats. So it's 5,940 seats. Let's go to part C now. Anisha visits the amphitheater. She estimates that the amphitheater has 6,500 seats. Calculate the percentage error in Anisha's estimate. The percentage error simply is equal to the percentage error, P dot E, is simply equal to the value approximate. This is the value approximate, is 6,500, minus the value exact, which is the 5,940, over the exact value, which is 5,940. I take the absolute value of this amount and I multiply it by 100%. So this is equal to, I need to use my graphical display calculator as well. I have inside the bracket 6,500 minus 5,940, all of it divided by 5,940, and I multiply this value by 100. So the percentage error is 9.43%. So it's 9 0.43%.